Hey, welcome to another episode of the Traverse Science Podcast. Today we have a repeat guest, Dr. Kelly Swanson, professor of animal and nutritional sciences at University of Illinois at Urbana-Champaign. And we talk a lot about fiber today. What is the definition of fiber? What are the structural components of fiber, the different subtypes of fibers, functional characteristics of fiber, clinical trial design, pitfalls in publishing. One time Kelly went and confronted someone at a conference for not describing fiber well enough. So this is great. Even if you're well-versed in fiber or not, it's a great place to just refresh, get the basics of fiber, and hear it straight from someone who studies this day in and day out. So enjoy. Good morning.
Good morning, Hook. Let's see. Better adjust my volume here a second.
All right.
You hear and see me okay?
I sure can, yeah.
Okay.
Did you have a nice fiber-rich breakfast today?
I had a little bit of fiber probably, but not. It wasn't so bad, I guess. I had a banana and like a little granola bar, so it doesn't get too exciting with me. But
oh, if the banana was too yellow, it didn't have enough fiber in it. You know?
Yeah, maybe I should have eaten an unripe one, get more resistant starch, I guess.
We have we literally put out a banana poll on LinkedIn because Kimberly, one of our consultants, assumed that everyone likes green unripe bananas. I'm like, she just like made this offhand comment. She's like, yeah, it's like the way everyone likes them to be, and we're just like, I'm sorry, what? You like them green? That's nasty.
Yeah, yeah. No, I'm fairly. I can eat them on each end of the spectrum, but if they get too many, brown spots on the peel or whatever, then it's like, oh, we're getting to a place where we need to make banana bread or something is what we say.
Yeah,
so
exactly.
So my family's range is a little bit narrower than mine, so they have to have that sweet spot. But it's pretty. It's like a day that that it hits that spot. So I'm like the garbage man that eats the rest of them. So
give him to Dad. He's the garbage man. He's gonna take care of it.
Yeah, they don't take any advice on restaurants or food from me because they just say I eat everything, which is pretty close to being accurate. So
close with your job.
Yeah.
That's like as a kid, if I went to school with a backpack green, I'd come home and it would be brown and disgusting in my backpack. It's like I'm not gonna eat. I don't want to eat that anymore.
Yeah, one of my daughters one time actually it ended up being an old banana in her backpack, but she was nervous that some animal had crawled in and died or something because she didn't know what it was. And so then, of course, I had to search it out and get it out of there. So I first inspected really closely before I knew, and they were like, "Oh, this is a banana. When was this put in here?" That was pre-COVID before they were, yeah. But still, it was. I don't know what was going on. So that.
I'm just imagining just this disgusting smeared banana all over the inside of it, just like a film.
Yeah, it took a while to wash that out. So, oh gosh.
What do you? I haven't really had breakfast. I'm just having coffee, and I want to have a episode on breakfast itself, which is a different topic. But what do you think about the trend of like a normal something you get in the grocery store plus fiber? Like, oh, it's pancakes, but now it has more fiber in it. Oh, it's soda, but now we've got some fiber in it.
Yeah. Well, it's kind of with some of the newer fibers, which we can talk about when we're talking about kind of some of those isolated or synthetic fibers. You can, if they're soluble and they're not very viscous, you can sneak them into all kinds of things. I know for a while, I'm not sure if it's still out there, but there was grape juice with a little bit of I think inulin in it or whatever. And pancakes and all kinds of breakfast foods are pretty easy to get fiber in. So. And so I, of course, from one of my fiber module I teach every few years in nutritional sciences, I'll buy a range of products and then I'll have the students, rank them in this category, rank how much fiber you think is there. And then at the end of the class, I'll kind of release the results or whatever. So sometimes it'll fool you. Sometimes it's, you can easily tell based on the packaging or whatever. But I usually hide the information panel so they can't cheat and just look at, of course, the side of the package. But usually after that class, then we have all these. I just buy them and then I bring them home. My kids like, oh, are these the the crazy pancakes or the normal ones, because they have the ones they like better, and some of them are, you can tell there's fiber there, and others you can't. So it really it depends on some yeah, the pancakes are probably the things they argue or they complain about the most. If it's not the right, I guess, fiber blend that they prefer, even the color will change on some of them, which again, I don't really care about the color of it, but
Coming back to being
it's
the garbage man of the family, to just eat anything.
yeah, yeah. So I've done some mixing as well. I mean, all right, a little bit of this, so we'll have like because there are actually some that will give you several grams of fiber per like pancake, basically.
Oh, yeah.
So you those are kind of the hardcore ones that are have the highest inclusion rate. But I do I get pretty serious when I'm searching for those, because I want some that have virtually nothing, whether it's cereals or granola bar type breakfast bars, whatever you want to call them, I guess. The really low ones, and then I have to search sometimes for the really high ones too.
Yeah,
so,
yeah.
But it's interesting. That's I guess the good thing, that you can get these fibers in that sometimes you can tell it, but this new wave of fibers, how it's changed the last probably decade or so, it allows people to kind of, I don't want to say sneak them in, but it allows you to get them in without having like, oh, it feels like I'm eating cardboard.
Right,
It's
yeah.
not it doesn't have
It's
to
a lot
be
more
have to
palatable
be
now.
that way. So, yeah, yeah.
Well, so maybe on that we can start with like, so how did you get into researching fiber in the first place? Was it always a big research focus for you?
Well, actually, when I was thinking about that it was, I think around 1999, when I moved from my master's work to a PhD, and that's when the first thing I did in kind of my PhD lab with Dr. Fahey was a fiber in vitro, and it was for pets actually, but they had a bunch of vegetable and fruit pummices and other kind of basically byproducts that are rich in fiber, and so we did a fiber in vitro, and that's really where we started. We're looking at dry matter, organic matter disappearance, short chain fatty acid production. In that one, I don't think we really looked at gas production or microbiota changes. It was just kind of the disappearance and looking at kind of the kinetics of it. How much could you put in a diet without too much of a good thing can be bad. So we were just kind of looking at that. So that's really when I got into it. So it's been, I was looking back too. When was the term microbiome even? When did that originate? And that was actually a couple years after I started in fiber. So I guess it's been a couple decades. So
Yeah. And when
a lot of things have changed.
you're doing those in vitros, that's, I think you kind of hinted at it. You're kind of trying to make sure it's like fermentable enough, digestible enough, not necessarily from the stance of this sort of like gut health, or like, were you doing them from the perspective of we want to make sure this isn't adverse to include in the diet, or really to find some sort of health benefit?
In there, well, in some of those, I mean, I guess you're always looking kind of at the potential health benefit. In those, it was sometimes those in vitro screenings. You're kind of looking at trying to predict the dosage, so you don't have intolerance issues, or tolerance issues. That's one thing. But then also, I guess if you have something where you can show that there's a interesting, fermentation profile. Well, of course, if you're measuring gas production, low gas is always the goal, hopefully, and then if you can push it towards butyrate, that's where if you can see a difference. And the fiber content, of course, the microbes that are there matter as well, but the type of fiber will kind of dictate that a little bit. And so you're kind of looking at the tolerance factor, but also, potential benefits from, again, at that time, it was almost strictly short chain fatty acids. I think now we could say, there's probably other things there. And with some of those fibers, actually, if they're coming from the fruits in particular, there's some, potential antioxidants that are coming with it and other benefits. Even with whole grains, if you have an isolated fiber, that's where you're like, well, is it still beneficial? Because with the whole grain, you have these other, whether it's B vitamins or polyphenols or whatever that are naturally there that come with it. And so I think the view has changed a little bit since then. But although even today, if we're going to do a fiber in vitro fermentation, usually you're looking at the main outcomes, how rapid and how extensive is it fermented within kind of a given range. It's logical, like practical, whether it's a day in fermentation, or oftentimes it'll go up to 24 hours, and that's about it. If you go beyond that, then you're you're thinking, well, in the normal in the gut, how long is it going to be there? Especially with a dog and a cat. With a human, you maybe could argue maybe the 36 hours, but
Yeah, it's gonna be shorter.
everyone's different, so it's hard to know. But yeah, you're trying to get some indication of, again, how some of the properties. You can see some of the viscosity in the tube as well. That will tell you something about what that might do to other aspects of the host physiology as well. But primarily, it's how rapid they're fermented and what's the outcome there and how do they differ. But yeah.
Well, maybe we can take a step back too and just do some fiber definitions. Maybe for the layperson, every time I think I have a handle on fiber, something else comes around and I'm like, maybe I don't have a handle on this as much as I thought I did. So like I was Googling, before that, what is fiber? Like, how would you define it?
Yeah, well, there have been many versions of it. And so certainly, really just the lay term, what I think about is it's the plant, the plant components that are not digestible by the host and may or may not be fermentable by the microbiota and the colon.
Yeah.
So they're not digestible. There is a category now that we kind of say is animal fiber, whether it's coming from insect protein or just other. People are interested in insects. There's chitin, and there's animal fiber, but traditionally the fibers are plant-based. They're not digestible, and so that's what whatever reaches the colon. Having said that, now we know there's non-digestible oligosaccharides, there's resistant starches, and so the group of, you think about the fibers is kind of a one. It's probably the main portion of the non-digestible carbohydrates, I think. But when it comes down to strictly to fiber, it's that. So you take this kind of the starch out of it, the resistant starch, the oligosaccharides out. I think to many people, what fiber is now is really the FDA definition is probably what matters the most and what they go by. If they're in industry, just because that's what they're allowed to say if it's fiber or not. On the package. Yeah. So and when their definition came out in 2016, it really kind of rocked the boat for a while that, whoa, what we've been kind of using is now, if you can't call it fiber, that's going to change a lot. And so they really had to, some people, had to petition and kind of make the argument, no, this is fiber. And then I think now everything's fine. But at the time it was a stressful time, I think, when that came out. But, so that's I guess the initial definition, but I think with FDA's definition now, they're certainly splitting out those that are intrinsic and versus extrinsic. So those either isolated or synthetic fibers are in a different category, and where you have to kind of prove that they are beneficial to health. Where the intrinsic, if it's there, it's fiber, right. And so it's a little bit. I mean, maybe it's not easier, but if you can measure it and you can show that it's fiber, then it's fiber instead of. There's usually research needed if it's some isolated or synthetic source.
Yeah. Well, I think we'll come back to that too, on synthetic versus quote natural or processed and not. There's probably three things I hear most when I read like definitions of fiber, and it's segregated by, aside from the FDA one, which is, I guess, different types of fiber. Is it soluble? Is it fermentable? And is it digestible? Based on what you just said, all of them are non-digestible, actually. So starting on the first one, what's the difference between soluble and insoluble fiber?
Yeah, it's really, you're looking at solubility in water. So you can, some like pectins and psyllium and things like that, you put them in water, they'll gel up really quick, and you can kind of see their water holding capacity by the way that it looks. Others, will be soluble. They disappear and it stays non-viscous. And then you have those on the other extreme is just insoluble, where not that they're like sand, but some of the celluloses and things they'll float to the bottom and they won't really interact with the water at all. So you can swirl them, you can heat them. It doesn't really matter. They'll stay in that form and kind of they really won't solubilize. So that's really all that it is, and that's a pretty good. Of course, we don't have just pure distilled water in our gut, but
right.
You'll get pretty good indication in a beaker or a test tube if it's going to solubilize, and then that kind of gives you a little bit indication of fermentability and viscosity, potentially viscosity as well, which is two other properties that, and water holding capacity. When you think about kind of stool quality, and this is, don't talk about it so much in people, but certainly in pets we do a lot. That stool quality, we all know what it is.
Right.
We don't need to talk about it, but in so much detail. But if the fibers hold on to water, that will change. Laxation, number one, just because there's more water there and kind of flowing through, but then actually stool quality will be affected by that as well. So that can be quite different across fiber sources.
Would you say, okay, so focusing on just solubility for a second, you can have a soluble fiber that is or is not viscous, right? And that's something that I think the first page of Google at least fails, which is why you should probably read more than the first page of Google. Because I was just trying to refresh myself with this. And you get a lot of these like, oh, they dissolve in water and become gel-like. But those are actually two very different properties. And we know from like working with pectins, which is not a single molecule, it's really like a class of pectin-like fibers. They can be viscous and they can also not be viscous depending on their structure, right? Is viscosity and water holding capacity the same thing? Or are they...
No, they're a little different too. There might be relationships there, I guess, that I'd have to think about a little bit. But and they kind of, to me, they have. So I'm not sure if there could be a relationship there, I guess. If it's viscous, it probably is holding on to more water than if it's just soluble. And if you think about the physiology side of it, that's where when you think about fiber too, I always think there's this disconnect of what can we measure in the lab, what is conceptually fiber, and then what is actually the effects, the physiological effects in the body. And so when you think about the viscosity properties, that's probably the most important, I think, in the stomach, small intestine. If you think about blunting glucose response and things like that, like benefits there, or maybe blood lipids. The water holding capacity, I think, from a stool quality perspective, you're kind of on the other end of the gut. You're in the distal end where you're in the colon. Now you're holding onto water, and if it's being fermented away, well, then that property goes away because it's not there. So if you kind of want a mixture, I think, of the fibers that are not completely fermented. If you're going to provide laxation and stool quality benefits, it's not completely fermented, so it's there and able to hold the water and kind of do that. So. So I'm not sure if I answered the question,
but I think it has. So coming just back to pectin, because it's easy to talk about. Like when we would do that in Ryan's lab, pectin would often be used, and I've seen it in a lot of papers, as a positive control, right? If you're doing it in vitro to look at fermentation rates and things like that. And of course, there's different types of it, for example. And whether you're looking at humans, you might want something that kind of blunts that absorption of glucose or alters lipid metabolism. For livestock, you might be a little bit concerned actually that you have too much fiber and it's like a quote anti-nutritional factor because you're trying to increase the amount of digestible energy in feed or metabolizable energy in feed as much as possible. And so that's kind of where it's so tricky to me, because if something is viscous or has high water holding capacity, I would assume it moves through the gastrointestinal tract more slowly. From that perspective, I would think there would be more time for more digestion and more absorption, in the sense that the digestible energy of that food or feed stuff would actually be increased. But in some cases, it's not increased; it's actually decreased. So it can be soluble, it could be viscous or not, it could hold water or not, and it could slow down transit time or not, and that may or may not also affect digestible energy. It's like, even just before even talking about fermentability and other things, just with soluble fiber, you now have like all these different dimensions. So it's really hard to sometimes, for me at least, to grasp like what is actually happening with these fibers.
Yeah, no, that's the thing too. Many times for humans and for pets, you might say, oh, that's a good thing because it can, blunt those curves and everything. But also it can, if there's a lot of fiber and it doesn't move, it can kind of serve as a, gut fill and for satiety reasons as well. So that can be a benefit. But on the livestock side, you might not want that, or even, some young animals, even, puppies and kittens. Usually you don't want, just for instance, but even livestock, if they have a small, especially the younger animals have to eat more per kilogram body weight anyway. And if they're feeling full all the time, they're not going to eat enough. And so even there could be not only just energy deficit, but nutrient deficiencies just due to low intake if you had too much fiber, and especially if there was a kind of a viscous fiber there. So in some, most people and pets, you'd say no problem as long as it's within a given range. But
very few people having too much fiber.
It's very
really not the problem. I think we need to focus on as as a country.
We're almost all the studies you look at, unless people are really, really being intentional about what they do and really trying to, they eat probably close to half or maybe up to 2/3 of the fiber, but very few people actually eat the recommendation. If 2,000 calories, it's about 28 grams of fiber a day. So the average woman, they say 25, average man is like 38. In our studies that we've done, it's usually between 15 to 18 grams a day is what people are typically eating. In my fiber module class, I'll do a project where people do it, and I think a couple students will go out of their way to really show how much fiber they can eat. So then they'll eat pretty high amounts of fiber, at least for a few days in a row anyway, if you believe their food, their dietary record. But long term, it's it can be done, but you have to really be intentional on what you purchase and what you consume and things like that, because you can say, oh, everyone thinks of, I think, eating salad, but you have to eat a lot of salad because it's 90 whatever percent water, and just lettuce itself really has really low levels of fiber. So whole grains and actually dry foods are easy to get fiber in, usually easier than you can eat a lot of fruits and vegetables, but then you have to eat a lot of it. It's definitely more than what your the dietary guidelines say, I think, to get your fiber. But really it should be a mixture anyway. That's where but that's where I think some of these foods where you can put fiber in there without making it hard for people. You can make it easy for them to here, buy this, and it already has fiber for it. Naturally, maybe 20 years ago, pancakes didn't have much fiber in it, but you can buy some now. And again, you don't have to get to the extreme of that high range if you don't want to. You can get something in the middle. Actually, adding just a little bit, usually in my experience, again, doesn't really change it too much. Like the palatability, and it's not too dense. The more fiber you get, of course, like pancakes and some of those things, they'll get more dense. That's just what it does. It doesn't cook quite the same, So, but
what we keep hinting at, and we'll eventually probably have a longer conversation on, is just coming back to that, adding it to other foods. So right now, there's a big push to be more food focused and less nutrient focused. Have whole foods, things that are less processed, which really gets tricky because now you do have the ability to enrich, I suppose, processed or ultra processed foods with fiber, and maybe it's more of a philosophical or maybe a policy discussion on, does it make sense to promote processed foods that also have fiber in them? I mean, if you do an RCT and you feed one group, here's the processed food and processed plus fiber, okay, the processed plus fiber is probably better. But maybe it's more a conversation of consumer behavior and what do they go buy, right? Should we be educating consumers to still avoid those processed foods? And this is what I talked to Christine Pelkman a little bit about too, because she was, I did a little dietary food record, and she kept telling me how, a lot of people don't realize how many B vitamins they get from enriched flour and baking products. And I was like, yeah, okay, whatever. And then I did the dietary record, and she showed me, and I was like, oh man, you're right. It does come a lot from there, from these very processed foods. I don't think I want to come out and say I'm promoting processed food, but where you get stuff it was a little eye opening for me. Back to the solubility part. So that was a lot on insoluble fiber. Insoluble fiber, is that just relatively inert until it gets to the colon?
Well, that's what I think. There might be things going on there. I suppose it depends on the source and what's if it's attached to something, from a nutrient digestibility perspective. But the fiber itself, it not much is going to happen to it, I don't think, until it gets to the the really dense microbial populations in the hind gut, that they still can affect, if you have a lot of insoluble fiber, usually they will kind of opposite of the viscous fibers, that'll actually speed up transit usually. So it can affect, and if you get to a certain level, of course, then you can, reduce digestibility in the stomach and small intestine. Part of that could be due to physical inhibition. Part of it could be, the transit rate, where again, in most people and pets, you'd be fine with that as long as the dose isn't too high or the concentration's not too high. In young growing animals, that's you could maybe have a concern there. There are some I guess I'd say on the pet food side, there are some weight loss diets that have 25 to 30% fiber, and a lot of them are the insoluble form. So and a lot of them are almost, they're not pure cellulose, but they're cellulosic fibers, and so most of that will go all the way through the gut, why it's so effective, because it reduces caloric density. But really, when you get to those really extreme levels, there are some people, and I think I kind of agree, like long term you wouldn't want to feed them all the time, just because there probably are some nutrients, like the digestibility of them is going to be reduced, and so long term that might not be good. Or most of those foods though are formulated, so here's how much they should be eating. This is how much, digestibility might be decreased. So then they'll usually increase the nutrient density of some of those, of the essential nutrients. So you can kind of do those calculations so you're not, coming up deficient. And again, I don't think most people would eat that much to worry about being deficient. I think it would be choosing the right foods, or, to avoid that. And, I don't know how well we do it anyway. Like you said, unless you do a dietary record, you probably don't understand where most of your nutrients are coming from. I mean, there might be some things, I ate meat or I ate beans or something, so I have amino acids and protein there. But I think as a whole, I think most people probably don't know where it comes from. And that can be an interesting exercise, to see. And in my class, I focus on fiber, but it gives you the whole readout, so I kind of look at, as part of that is how many, percent calories from protein, fat, and carbohydrates. So we do that as well. And even though the main focus is on fiber, I try to teach that, again, the balance that you hopefully have. And, don't get too excited one way or the other based on, I just say, just eat normally and you'll see what it comes out as. Because there's always a couple people that have like 5 grams of fiber, and they're horrified, and they're like, well, this, yes, you can improve your, selection, and it's, but I think most consumers are probably that way as well. So
the plus side there is you're starting low. It's going to be pretty easy to, you can make some really basic changes and improve your health at 5 grams.
Yeah, exactly. And like you said, nowadays there are foods where you don't have to completely change your entire lifestyle, because to do that is a pretty big ask for most people. We're busy, and it's hard to completely change it, but sometimes you can make a couple small changes, and for that you could easily go from 5 to 10 or up to 15 without making too many sacrifices to do that. So
I mean, it was helpful for me when I did the dietary record to learn, like the nutrients were interesting just from like a scientific standpoint, but then from what do I do now, it really was a little bit too complex to think about all the things I needed to increase or decrease. And so looking at recommendations of here's how much fruit and vegetables you should have per day, going that food route was helpful because I could just focus on one thing. I was having a lot of, my father-in-law, every time I would visit, would have a whiskey old fashioned. So there would be some orange in there. And then like, all right, well, I'm going to eat the rest of the orange. So I was like, that's an easy way to increase it. Probably too much alcohol there. But just doing like the one thing, like increase fruit, was a lot more manageable to do. But, life happens. And then it's even hard just to do that, to go from like one more serving of a given, maybe for me, maybe I'm bad at it. Yeah. But like dietary changes are massive. I mean, it's like behavioral change. It just takes a long time to redo your routine.
Yeah, exactly.
So we got solubility down, or we at least scratched the surface of it. Fermentability, that's an easier one, right? What's the difference between something that's fermentable and not? And you can have gradations between that, right? It's not like you're not all in, all out.
Yeah, that's the thing that when it comes to labeling, because when I started thinking about this, that kind of relates to the caloric content, what's on the label of what does fiber provide and things like that. And you can think about that physiologically as well. But yeah, it's really it can go from 0 to 100. That
Yeah.
you'll have some fibers that are completely fermentable. That means it's at some point in the gastrointestinal tract, they're going to be fermented by microbes, and so they are completely gone. And others, they're almost inert. Where some of these, especially with it depends on the type of fiber, but you have lignin, which is technically not a carbohydrate; it's a polyphenolic, but it's oftentimes with cellulose, hemicelluloses, and it measures as fiber, so we kind of include it in the calculation. But lignin is basically always inert; it's zero, and a lot of the cellulose in our foods is different variations. Unless it's been modified in some way, it'll have a low fermentability, which again, the key is to have balance, I think. So then you have some that's fermentable, some that's not, and that's not can be can serve as a laxative and have a laxative effect, and so that's beneficial too. So the benefits of fermentation, you can point to the short chain fatty acids and all the effects they have on the gut and on the host just in general. But then again, you don't want all of it being fermented either, so you have to have a balance there. And so, yeah, and very few are completely fermentable. Very few are, completely inert. It's just, when you think about whole foods, they have a mixture of different fibers. And unless you get to the synthetics or the isolates where it's, even those, there's a lot of one fiber type, but there might be other things there with it. It really depends on what you have there. But it's basically whether the microbes can break it down or if they can't. And so, we have, the microbiome was among people is very different and among animals is very different, but there's a lot of overlap there. So typically, even if you have, regardless of what bugs we have in our gut, they're going to be able to ferment certain fibers that, generally like pectin's are way more fermentable than the hemicelluloses, and cellulose is on the lower end, and lignin is basically untouchable from a fermentation perspective, and it's just not a carbohydrate, so it's not really broken down that way. But yeah, it's not either or. It's where it can be somewhat that way with solubility. It's different that either it's kind of soluble or not, and but fermentability, it's all over the board. And so that's where some of those in vitro, measuring it in vivo, regardless of the host, is very difficult to do usually. Where in vitros, it can give you at least an indication of how quickly will it be fermented, or will it be fermented? You learn that really quick. And then if it's fermented, what is it, what are the outcomes? And again, that can be dictated a little bit by the microbes that you start with. But if you start with, fecal inoculum from humans, dogs or cats or pigs, oftentimes the pattern is similar across fiber sources. It might be different between host species and what microbes were there to start with, but the patterns are typically pretty similar. There's usually not a situation where, in pigs, this is the highest fermented, and
I see.
Humans, this is higher. Like across species, they'll all kind of tell you the same answer between fiber sources, but still they can be, they can be different though. So you'd want to test usually the target species, the host, when taking fecal inoculum from those species to do the test, to apply it back to that animal.
I sat in on some presentations on in vitros, and there's a couple different methods you can do in vitros on individual. So if you're taking fecal inocula for your in vitro, regardless of host, right? You could pool them all and have a donor sample. You could have all individual samples. And maybe the point of this webinar I attended is that most people think the donor sample is actually an average of all samples. And it sort of doesn't even function that way. It kind of has its own little different profile, which doesn't necessarily look like it was the average of all the individual ones. And now I guess maybe I should have paid attention more, because I don't know what their takeaway was on should you continue to use donor samples or just go with individual ones. It's probably just a function of how much money you have, because it's easier to pool than, have a high sample size with a bunch of individual donors.
Yeah. We've done it both ways, to be honest. And I've heard people argue the one, and ideally you're right. I think it would be best we'll often have, 3 or 4 donors, or actually you have maybe a pool of 10. So with some of the animals, they'll you'll whatever 3 or 4 go first, those are the ones you take. And with people, it's kind of the same way that, okay, who donates first? That's the ones we're going to use.
It's ready right now. Gotta use it.
Inoculate the tubes and go. But if you pool, there is some thought that, is there some then this microbial struggle among, if you pool samples, that now there's some of that going on in addition to fermenting the fiber that's there, or the substrate. If you have individual, like the pecking order or whatever, the population is what it is, so it'll be more natural. So, but still, it is even, like, again, that first fiber in vitro I did, we had 3 donors, and that was just from dogs. And so it's only an N of 3, but you will see some differences there, and just whether it's hard to distinguish, I suppose, at some level. Is that the biological variation, or is there some technical variation, in the laboratory as we're doing assays and stuff? But typically in those in vitros, you have triplicate for each substrate, time point, you have triplicate tubes. But then if you'd have a few donors, you'd have, really at least 9 tubes in a blank, to do that at each time point. So you try to put some, technical replicates in there as well, so you believe the data that you have. But yeah, you'll see some variability. Very few people, of course, usually people are looking at healthy. It still would be very interesting, though, to see if there's an animal population or a human population with, IBS or IBD or something. Okay, how do those bacteria respond to the fiber, and what do they produce? And I think there can be some things in vitro that could help us connect some dots there. They're not often done too much, but again, I think it could be useful with IBD. Also, it probably, whether there's a flare up or not, depending on where that person is, could also be impacting what the results would be, which would, again, you don't see many things like that. Most of in my experience anyway, it's some of the food companies or feed companies are looking at having this in a diet of a healthy human or animal, so they're not looking at that aspect of it. But I know there's other in vitro systems where they're more, ours, you can kind of build it up, you get your inoculum, you do your study, and you can kind of tear it back down, because it's not a huge complicated structure or anything. So, but there are some elaborate systems that it takes might be days or weeks to kind of stabilize everything, and that's a little bit different scenario. That we were talking about. I guess the way we're set up, we do it the kind of the previous way, where you can kind of build it up, do your study, and break it back down. And so it's still a few very busy weeks to get that all
it's a lot of work.
But
how much?
But I think it translates fairly well to in vivo.
How much would like one subject having diarrhea, or would you do like a Bristol stool scale on the samples going in, and one being constipated, hard and dry, I think 3 to 4 being normal, and 7 like watery diarrhea. If you had one sample that was basically diarrhea and the others were normal, do you think that would have a huge impact on that pooled sample?
Well, it could, and that's where I suppose it would depend on maybe why is one a 1 and why is one a
right?
7,
They're not all the same reason.
It could be if it's due to because you can get loose stools from from various different things, but assuming it's
sometimes seemingly no reason at all.
Sometimes you're like, what was that? But now it's over and I'm good. I'm fine. But something had to leave early. So, but in our pets, usually we wouldn't use a sample that was would be diarrhea. If that morning someone was not feeling right, whether it's animal or person, we would say, okay, that we don't want to use that one. But that would be an interesting study as well, because we've known, you've already mentioned kind of transit time, but water content would be another thing that, okay, are we adding the same amount of bacteria to each one? If you're just random, or I don't want to say randomly, but if you're not thinking about that, a really hard feces, and you take 50 grams of that and put it into your buffer and your media and kind of make your slurry, and then you start injecting, the microbial density could be very different than if you had a sample with diarrhea. Okay, and the bacteria could be different as well, so it gets kind of complicated. You'd want that's an interesting study, though, that if you'd want to test that alone. Something similar to that. It's a little bit different than what you're saying, the scenario, but in the past in a cat study, we actually had cats that were for I think about 2 weeks. It was one of Fahey's students, but I was on the committee and on the paper where cats were given either a diet with inulin, or I think it was with pectin or cellulose. And so we had 3 groups of cats, and then we collected and then did in vitros on those same substrates to see, okay, if their bacteria are used to fermenting pectin or whatever, what's the fermentation rate of those versus the inoculum coming from other cats. And so, of course, in that first time point, when that first pull came, it was a little bit different based on what the bacteria were kind of used to seeing, in the cat. So, and that would probably apply here as well. That's where I think, we don't want to go into that discussion, but like FMTs and things like that. I think whoever's donating for microbial transfers, that's a huge factor in my opinion, that someone should do that study, that, the donor collection, how do you do that? And then what is that person eating to, provide you with this sample that should be, repopulating your gut. Yeah. So I think it applies there as well. But certainly, it would for a few reasons maybe dictate the bacteria, but then the water content, and even, if there is diarrhea, the behavior or the activity of those bacteria versus something in a constipated sample is probably different. And and I guess we're focusing on bacteria as well. Methanogens, and some of those are slow growing, and they're shown to be more prevalent and more constant, like slow transit rate as well. So there could be other microorganisms, I guess I would say in general, that could be different too, that could change it. At some point though, someone's going to have an advantage and ferment it. And so I guess if it's on the extremes, you could have very different results potentially. With most quote unquote normal samples, I think it's probably less variable that way, but still that's where all these, you lay out all your details of the study, and something like that could really throw a wrench into it, that, whoa, why is that one so different?
You've got like 10 variables, and you're like, well, you got to pick like 3 that you can control and deal with the rest of them in your discussion.
What can you control as much as possible? But even in those studies, with dogs and cats, oftentimes they are eating the same food, so we have it consistent. But in people, I mean, oftentimes they're eating their regular, what you'll see in the papers, they're eating their regular diet, which can vary, of course. And so you'll get some.
That's interesting. Would you, I gotta like write down all these questions. I don't even have time to write them all down. So when you do, in a lot of studies, when they do a food record, or whether it's food frequency, whatever it is, they might do them over a period of time, like 3 days. And then you're using that as a quote average for that time. But when you collect samples, I think I see a lot of they collected a single sample on a single day. Would it make more sense to have collected it over those same 3 days that you recorded their food from? And maybe pool for an individual subject, their samples pooled over 3 days, and then you could or could not pool everyone's together?
That's another, on the in vivo human studies we've done a few like that, where we actually, when we're looking at the microbiota, we'll have 3. Often, so for some people, it's not three consecutive days.
You're right.
But
that's
within
hard
about a week's time, it's we try to get 3 fecal samples, and then we'll extract the DNA and then pool the DNA is what we've done before. Within in vitro, it might be a little bit more difficult to do that based on the viability of the bacteria. But I do think it's more variable in people. And like you said, there are some people now that I know Dan Knight's group in Minnesota, in one of his papers, Johnson was the lead author on this paper, but they kind of looked at 3 or 4 days ahead of time of those samples, looking at what they were eating and kind of using, yesterday was more important than 2 days ago, but they had some kind of a strategy there to not just use the day ahead. It might be a couple days ahead, and they had I can't remember the exact formula or the way they used it, but I think that is important, and because transit rate is different for people, and it was a way, I think it helped normalize things a little bit better, or at least relate to the diet. Of course, what I eat right now is not probably very relevant to what, if I be TMI here pretty soon. But if I were to go to the bathroom
Yeah.
and 3 hours from now, what I just ate is probably irrelevant from a
Oh
microbiome
yeah,
in
yeah.
the fecal sample perspective. So you have to think about that. And
They need a line item in there for like when was the last time you had coffee, at least for me, because that's pretty
yeah,
different from like the rest of the day. Which I mean,
yeah.
that comes back to a lot of the whole like chrononutrition, chronobiology, all of that, circadian rhythms and things.
Hmm.
But when you talk about normalization,
Yeah.
so here's the simplest example is whenever we were doing short chains, we were taught always, always, always adjust for dry matter of the sample. Like that's just
Hmm.
you just need to do that.
Yeah, yeah.
um, not everyone does. Would you also adjust? Is there a way to adjust like gas output, for example, for dry matter going in?
Well, ours is usually, yeah, it would be, I don't know, probably milliliters. We'd measure it kind of in a volume in
Yeah.
milliliters of gas per
Okay.
gram of whatever the substrate was, is I believe our
Okay.
unit.
Yeah.
So you kind of come back to that. I guess on that one we were looking at I guess for in vitro we were looking at how much of the substrate was there. Kind of went back to substrate, but
Hmm.
um, yeah, for if you think about fecal samples or even um, fecal samples, I guess, yeah, we go to grams of dry matter is how we do it because I still think that's the best way to kind of normalize
Yeah.
that. Again, you could maybe make arguments of, well, why is there more loose stools than solid stools? But um,
Yeah.
and so in vitro too, when you look at short chain fatty acid production, it's usually then it's based on how much substrate was there at that
Yeah.
level. But
Substrate
but
being
yeah,
the fiber or fiber plus the fecal inocula.
it is the fiber, and there's always blanks in there
Hmm.
where you put the inocula in but no fiber, so you kind of use that as your control to subtract
Okay.
from. So if there is any, yeah, like you said, there's going to be some level of fiber in the fecal sample
Right.
itself, and
Or just
and
other
that
dry
we'll measure
matter
there. So
components.
yeah, so you can use that blank sample to kind of calculate that, and actually usually have a blank sample that goes all the way
Mm.
through, but you have an initial 0 hour blank as well that everything kind of gets can get
Yeah.
compared to. But you're right. Even there's going to be even short chain fatty acids are in that fecal sample, so you have to use that as a blank to do some math there.
Mm.
That okay, if you're already starting with a little bit of acetate or propionate butyrate, it doesn't end up being very much in that initial, but you're going to have something there. It's
Yeah.
not zero, so you have to
Adjust for that.
kind of zero it out using that. So
There.
um,
Yeah. There. I'm trying to think of like um, if there's probably too many variables to include in like one nice little regression or equation, but um, you could look at like the Bristol stool scale, which I think is partially accounted for if you've collected dry matter. You know the inverse is water content, so maybe that's irrelevant to look at the consistency of it. Um, so you could use dry matter as a covariate or just adjust for it directly. You could use bacterial load, which then you get into this crazy thing of like, okay, well, which of the like hundreds of taxa do you want to use as like your covariate
yeah,
if you were to do that? But that almost
yeah.
feels kind of relevant. Like when you're talking about people with maybe IBS or even if they don't, what's the starting point just seems so relevant to how you're going to interpret that.
Yeah, that's where I think if you do, you're quote unquote healthy, or think about healthy individuals, there you go. Set up your study and do it. But like you said, some of these other variables, it probably does matter, and especially in some of the, with IBS, IBD, whatever the condition might be. Like, okay, well, why are they different? Maybe you could set up a study to look at some of these more specific things that oftentimes we know that are there, but you can't account for them really because like, well, this is how we set it up. So these variables are there, but
Yeah.
we don't know, how much it contributes, and so we just kind of say, well, we acknowledge that it's there, but you don't do anything about it.
Hmm.
I think in these you could do studies, especially if that's your area of focus. You could do studies and you could set it up, I think, to look at that a little bit more. That
Oh, yeah.
to try to tease those out, at least in that population where it's probably the most relevant too. But
That's a good
um,
point too, and might make more sense um, about the I guess selectivity of a fiber to be fermented by certain bacteria. So Okay, there we go. We talked about solubility, fermentability. Some fibers, are they selectively fermentable? This is getting into like prebiotic-ish territory. Like, is it fair to say there's like broad spectrum fibers, and then there's those that are specific for, or maybe more available or rapidly fermented by a given bacterial taxa?
Yeah, I think that's where, kind of in our correspondence before this, you kind of had that in the prebiotic versus fiber. And I think that's what kind of distinguishes it. That hopefully, I mean, if fiber, I guess, given all the data that's there with fiber, if it's intrinsic, you know, you don't have to stimulate any population of bacteria, but you can have a lot of, I mean, fermentable fibers, like you said, there'll be some of those broad spectrum where, at least, especially if you have whole foods, because it's not just one fiber source.
Right.
You'll have some pectin, some cellulose, some hemicellulose is there maybe, and so it'll be kind of you can feed a lot of the bacteria, but then you have the others, and I think that's where the kind of the prebiotics come in, where it's been more selective, where you have to show, again, under the prebiotic, it has to be the three things. It's got to be non-digestible. It has to be selectively fermented,
Mm-hmm.
so not just anything, but kind of a beneficial bacteria in quotes, and then you have to show a health
Yeah.
benefit. And so those are the three things that, our correspondence as well is like, oh, what's changed since you've started working with fiber? I think one piece of it is that biotic field has kind of grown over that time, but also a huge thing that's changed all the molecular tools. So again, microbiome wasn't even a term in 1999 when I did that at first in vitro. And now we have all these molecular methods to really look at the bacterial populations at a different view. So I think we've realized some of the prebiotics aren't as selective as they used to be. So that's where there's been some controversy over the prebiotic term. But I still,
Uh,
in my head anyway, the prebiotics are more selective. So some people will say, I guess I don't agree with it, that, oh, pectin, or on the pet food side, oh, beet pulp is a prebiotic. I don't think it is. It's not that
Let's get
selective.
into it. Yeah.
So the problem is, where's the line? And that's where people argue, well, how selective does it have to be?
Yeah.
How many tax are, so it is a
Mm.
it is a difficult thing. And I think that's the kind of the distinguishing point, is that selectivity,
Yeah. Okay.
um, and but in fiber, I guess on that side too, you can have, most prebiotics are a fiber, but not all fibers are a prebiotic. So because there are fibers that they might be completely inert in providing laxative benefits, and might provide, they can lower blood lipids or whatever it might be, but they're not being fermented. Where a prebiotic definitely has to be fermented and selectively fermented, and so that's, I think, the difference is
Yeah.
there. And in all, people argue about that. I think if you have a mixture of all of it, that's great. That's what you should have.
Yeah.
And so not, get too one dimensional in any way. If you can have a mixture of all of them, I think you can get the benefits of all of it. So
That.
that's typically, especially on the pet food side, it becomes more of an item or an issue, I think, because you have a complete and balanced food, where most
Right.
people, you're providing products but they, in the end, they have to kind of hopefully making a complete and balanced diet, which some days I know I don't
Right.
do that
Yeah.
either. I'm like, wow, I really need to get back on. And, not that I think day to day, oh, what am I going to eat today?
Yeah.
And I usually don't plan out that much, but in the pet side, and a lot of livestock as well, like, that's what they're going to eat. So you have to think about that, and what kind of blend, what dose you're going to have. And it depends on the life stage and what you're kind of formulating to do, but you have to think of it, I think, more holistically, and not get too one dimensional. And sometimes cost will just dictate that you just can't afford to have
Right.
one thing. But you'll see a lot of the prebiotics and the fibers. And kind of back to the food, the processing side, it's funny that in pets and people, with increased processing, and I don't want to be anti or pro any type of food, but with a lot of the processing that goes on, you remove the fiber, and now we're acknowledging, okay, we've taken it out, let's put it back
Right.
in. So it is different than the original matrix, I think, but still, you can have, your, whether it's fortification or enrichment, depending on what you're talking about. If you're putting it back, I think that is a benefit. And there are some pet foods that are doing the same thing now too, that you have this ingredient profile, you want it to be very digestible or low stool volume, whatever you want, but then we're seeing, well, we don't want them to be constipated either. So you add a little bit more fiber back in, or so the formulation strategy is very different based on the base formula you have and kind of your, whatever the claims you're trying to make, and things like that. So it's yeah, there's a lot of similarities with humans and pets, but it is different than that. If it's a complete and balanced food where they can drink water and eat that food, it is a different strategy than most human foods have, other than, if you have, infant formula or Ensure, something that could be,
that's extremely processed
just
right
that
there.
food item. Yeah. So
if you could, on that kind of like food matrix point there, let's say you could theoretically extract just fiber from the fruit, and one group gets the fruit in with everything intact, and one group gets it with the fiber extracted and then put back in. Do you see where I'm going? Does the matrix matter?
Yeah.
If it's, I guess obviously based on like the FDA definition, yeah, matrix is like everything, whether it was isolated or not. But if you were to just take them together, does it matter if it's in the food, or do we know the answer to that type of question? Like,
we probably don't. The one thing I tend to think it is still different. I think that's why FDA, kind of the rules are the way they are, that if it's isolated, you have to prove that it's a benefit. Because I think in that isolation process, one, the particle size could be different, but that food matrix could be different, and depends on the source, I guess. But I think in like a lot of the whole grains, there certainly are some of the other essential nutrients that are being stripped away. Where if you just add the fiber back, you're not adding those components back necessarily. With some of the fruit, you think about the fruit juicing industry, kind of a lot of those pulps and fibers go away, and even when you haven't, based on what I understand, what the people have said, even if you have orange juice with or without pulp, a lot of that, the fiber is still gone. Even if the pulp is put back, there's still part of it that's not there. So
this was a watershed moment for me. I went to go get the high pulp orange juice. This got the same amount of fiber in it as no pulp. I was like, who is even eating this then? There's no reason to have this.
Yeah, so there are, and that's where for a while, I was in the same boat. I thought, well, I want that pulp back. My kids didn't want the pulp. I don't want that in there. And I like the pulp. But then, the fiber content, it really is not really different. And so there's still other fibers that haven't been
How's that even
put back
possible? Is the pulp not does it not fit the definition of fiber?
I'm thinking that maybe
or maybe it's just in such a low concentration or something that it doesn't make it on.
I think so. So I think at some level there must be fiber there, but I think given the serving size, it must not reach a level that allows you to bump it up. But or you'd have to add a lot more to it. So I suppose then there'd be way too much pulp for
anyone to want to eat it. You haven't
you don't want to chew your orange juice or whatever. So.
The consistency of oatmeal. Yeah. Like if I took a high pulp orange juice jug, I could run that and do like a total dietary fiber, right? And I'm gonna get something out of it because I'm like, there's pulp in it.
Yeah, there's got to be some there. I'm thinking it's those, whatever the pulp is made of is not as, when I first thought that, I thought, how is that possible? There must be, other carbohydrate based components, that there must be some digestible fraction. So it's not all fiber, I'm guessing, but I'm going beyond what I know here. Sure. So I don't want to speculate too much, but I'm guessing it's not as fiber rich as what we probably think it is, but just, you hear orange, that's where a lot of these pummices come from, orange and apple, and anything that you can juice. But even you think about, the little mini carrots and stuff, that of course the carrots aren't grown really smooth and everything like that you buy in the little package. Where's that other part of the carrot going? So there's a lot of other secondary products. Some of them go to pet food. Some of them might be, I'm not sure if they're recycled they could be recycled maybe in the human food side as well. That there's nothing wrong with it. Eating a carrot, those the parts that are kind of being shaved off there. And that's where some of the research we've done recently have kind of looked at, initially it was on the pet side, but even on the human side, say, well, what if we were to add something like this back into a food product or a drink? What can we, is there a benefit there? Can you show benefits? And so, but you're right. I think that you kind of have to prove that then it is a benefit to add it back. But unfortunately, I think again when it's isolated, it's probably more so just the fiber. But if you take it away, there might be other components that are kind
Certainly,
of linked
yeah.
to it. So that's where I think the potential, I want to say potential difference could come in.
Yeah.
It's not guaranteed.
So that's
And that's right.
okay.
Yeah, go ahead.
Well, this is top of mind right now because we have a few projects going on about like food matrices and how that impacts health. Isn't that the most broadest way I could describe that? Food matrix, like, okay, food. Um, and so, like in your example, the argument might be you isolate a given fiber. That fiber was in a quote matrix with other things, maybe vitamins, minerals, polyphenols, whatever it is. Pectin, for example, its gelling properties are dependent on how much calcium is in a solution. So I can understand from that perspective, like, well, hey, if you've changed the amount of calcium in there, it's going to have really different gelling properties, and that can affect, water holding capacity, laxation, etc. And so sometimes I'm like, well, the fiber is still the fiber. It's still the same thing. So if you were to still add that fiber plus the calcium back, isn't it now just the same? I guess it's impossible to study food and take both a reductionist and holistic approach at the same time. And
Yeah.
I know, I had learned that if you feed animals, switching to something that is seemingly easier for me to understand for a second, which is protein. And protein is made up of a bunch of amino acids. And when you digest protein in the stomach and in the small intestine, it's digested into tri and dipeptides and amino acids. But if you were to feed an animal a diet that had the same amount of protein, no. Feed two animals the same amount of amino acids, exact same composition, but one comes from protein sources and one is just like crystalline amino acids. The ones with just the crystalline amino acids do not grow as well, which speaks to there's something important about the inherent structure of those proteins. Or maybe it doesn't. Maybe it is something special about a couple of di or tripeptide sequences. I guess the same concept applies to intrinsic versus extrinsic fiber, but for me it's really hard to prove or understand those things. And like if we talk about sugar for a second, there's a lot of debate and discussion about added sugar and safety of it or not. And you have some people going, well, sugar's sugar. Glucose is the same regardless of where you find it. And then others are like, well, glucose in fruit is different because it's accompanied by fiber and other things. And that confuses me because I'm like, well, now I think you're just talking about fiber and you're not really talking about glucose anymore.
Yeah.
Obviously, sugar alone is different from sugar plus other things. And I'm rambling here. I don't even know where my point is. I guess my point is I can see why people are a little bit peeved or upset about the FDA definition because it's like it feels like all these intrinsic fibers are shepherded through despite there being no need to actually show that there's a clinical benefit to consuming those types of fiber in those fruits, whether it was beet pulp or something else. And some manufacturers have put a lot of work in, not who cares how much work they've put in, that's not the point, to isolate and study and show clinical benefits. And it's just really difficult sometimes to show clinical benefit. So perhaps my point is, we can talk about how the whole food matters, but I sometimes think it's really just poorly understood. Like, does it matter for a given health outcome? If you want to prove laxation, do you really need all those vitamins and minerals or polyphenols, or can you just have the laxative component of that fiber and that is good enough? But
and that's where I think you're right, because it depends on what you're starting with. Certainly, like you said, even pectin, there's high molecular weight, there's low molecular weight, and they will have very different properties. And so that's where I think with these isolated fibers, it's probably more, it's easier to show, oh yeah, of course, it's like the intrinsic, where others, if you process it to a level where either the molecular weight or the, just the particle size, that even that, like fermentability rates, or like you said, water holding capacity or whatever, those properties could change, the viscosity. So I think, but so you'd say, well, they can be different, but if your goal is, or your outcome is laxation, well, then it may not matter, so you can prove it. So it probably, it depends on your outcomes and it depends on in that isolate or whatever you have, is it purely that fiber? Has it been broken down? Is it still the same molecular weight? So all those linkages and a lot of them are, I kind of tend to go back to amino acids as well, that it's in many ways, and I know it can be complicated, protein structures and stuff, but at some level, these amino acids, if it's, linked to each other in the same way, when you get to sugars, they can have all kinds of alpha beta linkages and all, it gets really complicated really quick when you think about the fiber matrix, because it can be these huge structures of many different linkages. And so if you're able to break those down, if you think about cross feeding in the gut, that's where the particle size can become an issue, where if you break some of those apart before they get to the gut, now other microbes might be able to break them down, so the fermentation rate will take off, where in its native form, those initial bonds, whatever it would be, the rate limiting factor, it might just really take it a while to get going. And so that's where I think on the processing side, if you're decreasing the molecular weight of that could have a huge impact. But it depends on what it is. That if the structure's got the same linkages all over, maybe it doesn't matter. But if it, but maybe it does too. I don't know. If you even look at amylose, amylopectin, if they can pack themselves really tightly versus if they're, some of it could be just enzymatic, access or something as well. There could be other things at play there, but that's why I think, again, it comes back to the FDA. I think that's why they did that, to say, well, it's not the same as in its native form, so you better prove to us that it's a benefit. But there's been some heartburn over that, and especially what you can call, as being a benefit, because, even though the microbiome field is just blown up in the last decade or more, you still can't, the microbiome as a measure is still a secondary measure. It's not a health outcome. Exactly. And short chain fatty acid production is not a health outcome by itself either. It's part of I think a part of the process, the physiological response, but on its own, it can't be used as a health outcome. So, and there's been some people that don't like that. Right. And so I guess I kind of agree with it, but on the flip side, we could easily, both of us, design diets so we're going to change the microbiome profile and the short chain fatty acid production. Exactly. But just looking at a person over a few weeks, it won't tell you anything about their health. Exactly. So and that's part of the frustration, I guess, of the field. That why can't we just know what's healthy, what's not healthy, and why can't we, But it's it was simpler, 20 years ago.
20 years ago. Nostalgia.
You'd measure a few bacteria and make a judgment on a few bacteria, and that's all that you would do. So it's a little scary, but it was. And a lot of people still want to be in that situation, but it's hard to ignore all the other things that are going on. And so
I mean, there's a lot of different interests at play. If you're a food manufacturer or an ingredient supplier, you're obviously going to want to do as little as possible that it takes to show that your ingredient is healthy or has a benefit. And it's pretty easy nowadays to just collect some fecal samples and look at short chains and microbiome. And I totally agree with you. That means nothing about overall health.
On its own, it really doesn't tell you much.
Well, I wouldn't say nothing, because sure, you can look at relationships between given pathogenic bacteria or whatever. If you're trying to show that it's healthy, just what is it healthy for? Just show the actual end point, and that's the stance that FDA and the European Food and Safety Administration have taken on things. That said, it's understandable. Clinical trials are really expensive, and when you think about how a fiber could have different molecular weights, different branching patterns, different residues and blockiness, you would need to do dozens or hundreds of clinical trials to figure out the optimal, factors to make that with, right? Like you have all these levels, and it's like factorial or however combinatorial. You have A times B times C times D, and all of those individual things have like hundreds of levels. So you've got truly hundreds or thousands of different types of combinations of just a pectin or fiber that you could have. But and you talked earlier about how the definition has been changing and how selectivity is related to the prebiotic definition. And I was going to talk about, you already answered it for me. Like, fibers can be prebiotics. Prebiotics are not always fibers. There's like debate about the selectivity issue, but to me it's like, I don't know. Maybe are we too focused on definitions? Is it a fiber that's prebiotic? Does it do the health benefit? That's probably what an end person only cares about. Is this gonna make me feel better? But that's where a lot of interests come in play, because people really want to be able to say on their label, this is a prebiotic. I guess regardless of how well it might compare to some other fiber, right? Like, oh, it's better if our fibers are prebiotic, not just fiber.
Yeah.
Like if our benefit is only in the small intestine, that's a bad thing. We need it to be in the colon too. It's like, no, that's still good, even if it's not a prebiotic. That can still be good.
Yeah.
Hey, thank you so much for tuning in to the Traverse Science podcast. If you'd like more of this content, check out our website on traversescience.com. You can follow us on LinkedIn, subscribe to us on YouTube, and you can check out the podcast audio version on Spotify, Apple Podcasts, and Google Podcasts. All right, take care.